So now we're going to do the word problems from section 4.1, and you do have to have these formulas memorized. And so we're talking about compound interest, and this is if you're compounding monthly, quarterly, annually, those kinds. I used to have my students call the banks and get their interest rates, but right now interest rates are not so good, so I will not make you call your bank and find out the interest rates. But let's talk about the different pieces. A is going to be the amount in the account after the given amount of time. P is your principal amount, so what are you starting with? The T has to be in years, and normally it will be. R is your annual interest rate, but make sure you put it as a decimal, so get rid of your percent sign by moving it twice to the left. And then N is the number of times it's going to happen per year. So if I said that it's compounded monthly, N would be 12. If I said compounded semi-annually, well, N would be 2. If I said, what else? Quarterly, N would be 4. If I said daily, 365. But the next formula you need to understand is that the formula for the interest is compounded continuously. Then that's when you're going to use a formula we call PERT. A equaling P, E raised to the RT. There's that E already. So P is going to be the principal amount, and R is the rate, and T is the time. Again, we know what E is, and we'll use E from our calculator. But again, the only time you use the PERT formula is if it's compounded continuously. So how much will $50,000 be worth in 10 years if it's invested at 8% compounded annually? So how much will this be worth? So this is my principal amount. T is going to be my years, that's 10 years. My rate is 8%, but put it as a decimal, so 0.08. And then we're compounded annually. So the only time this has happened is when N equals 1 time a year. So let's write the formula, because again, you do need to have your formulas memorized. So make sure you understand that we're going to use the first formula. My R's and my N's sometimes look a lot alike, so make sure you understand that the R is on top, the N is on bottom, and then it's raised to the NT. So plugging this into what we have, as we know for our P, we have 50,000. And then 1 plus, the rate is 0.08 over N. N is 1 time per year, raised to the 1 times T, and T is 10. Now if we were in a classroom, I would have all of y'all type this into your calculator, because it is interesting how many different answers we get here. But since we're now having to do this a different way, let's go ahead and show you how to plug it in. So we have 50,000 parentheses. We're going to plug in just how it's written, 1 plus 0.08 divided by 1. The calculator will read this correctly. Now, when you raise your caret key, raise it to a power, if you have a parentheses that opens up, don't close it. Do 1 times 10 and then close it. Or just do 1 times 10 in your head, which is just 10. But if you don't keep your parentheses open, then you won't get the right answer for that exponent. So again, if you hit enter, then you should be getting that. Make sure you can get that correctly into your calculator. Since we're dealing with money, we'll round to the nearest cent. So we'll look at the 4 and round if it is a 9, so we do round. So it's approximately $107,946.25. Make sure you put the dollar sign. So it says $107,946.25. So now we're going to do another problem, again using compounded quarterly. So what does that mean? So the compounded quarterly, you know you're going to use a formula, A equaling P parentheses 1 plus R over N raised to the NT. Your principal amount was your P of $1,000. Your rate is 6%, so 0.06. Your T for time would be 40 years, and it's compounded quarterly. Quarterly means N would be 4. So plugging this in, we have $1,000. 1 plus the rate, changing it into that decimal, 0.06 all over n was 4, raised to the 4 times 40. So plugging that into your calculator, we'll do it again together. We have $1,000, parentheses, 1 plus 0.06 divided by 4. The calculator will read that correctly. Raised to the, and then 4 times 40 is 160. Again, you can just do 4 times 40 if your calculator keeps it all as an exponent. If it doesn't, make sure you use parentheses. So we're going to end up with $10,828.46. So approximately $10,828.46. So I'm going to let you try 3A, B, and C. So I'm going to circle those. And I might ask you to submit that, or at least to send me the answer so I can make sure you have them correct. So, the other kind of word problems we have to deal with are depreciation. And if you see what I wrote at the top, it says there are no problems like this in the homework or in the book. So make sure you look back at these because this will be on your test. KBOR, Kansas Board of Regents, asked us to make sure we cover depreciation in college algebra. But none of the college algebra books actually have it, so we're just supplementing it. This formula I will give to you. You do not have to have it memorized like the other ones. Since you won't have any problems to try in your homework over depreciation, I will go ahead and give you that formula. V is the depreciated value. You don't have to do anything to get to that value. Once you do this formula, it'll tell you what the depreciated value is. P is the initial value. R is the depreciated rate, again as a decimal. And this time can be anything. It doesn't have to be in years. It could be in months. It could be in days. So you get to keep T just as is. So we have a price of a new car of $25,000. It depreciates by 18% each year. Find the car's value at the end of 5 years. So V is going to equal P parentheses 1 minus R raised to the T. Again, I always write the formula because the more you write it, the more you remember it, although I will be giving that one to you on the test. So the principal amount was $25,000. I'll have 1 minus the rate is 18%, so as a decimal it would be 0.18. So 0.18, and T is going to be 5 years. So plugging that into my calculator, I have $25,000 for a car minus 0.18. And we're going to raise it to the fifth. So after 5 years, we want to know how much is the car worth. And the car is going to be worth $9,268.50. So definitely depreciated quite a bit. So the car's worth is $9,268.50. So things can also depreciate monthly. They don't have to depreciate yearly. So we want to find the value of a TV after 15 months if its original price was $1,200 and it depreciates by 8% per month. So again, the formula V equaling P parentheses 1 minus R raised to the T. We know that the original price P was our $1,200. The rate is 8%, so as a decimal 0.08, and the time is 15 months. Again, we can keep it in terms of months. So we have 1,200, 1 minus the rate 0.08 raised to the 15 months. So let's see how much our TV is worth after. So 1,200, parentheses 1 minus 0.08 raised to the 15. And we'll see that our TV is now worth $343.56. So $343.56 after 15 months. So I'm going to give you the answer to number 3. You can try it out, but the vehicle that was originally bought for $125,000 that depreciates actually going to be worth approximately $29,663.09 after 5 years. Big depreciation there.